Hey, so I've been doing film photography for a few years, but it's only in the past year, 2024, that I started actually scanning those. So now that we can say goodbye to 2024, I thought it would be cool to share the workflow I've been building for the past year, especially considering it's not that usual, I dare say. So it may spark some interest in the most thinkers out of you. Due to my background, what I'm going to showcase might be a bit technical. There are going to be small coding part because obviously as a software developer, I couldn't resist and I had to write my own script. But I try to make the explanation as clear as possible, so hopefully any of you could at least catch something useful. And last, quick disclaimer, my workflow is very subjective. I want targets accurate or better than anything else. It's tailored for my need and shaped by my background. So your knowledge may vary for anything that I will show. And now let's have a look at what is going on the computer side. Just so you get an idea of what I managed to get with my workflow, here is some example of what I've been scanning this past year. These are some of my personal favorites in an arbitrary order. But yeah, I think I'm at least very satisfied with the result, or at least the positive development workflow. I think I don't lose filmic rendition you can have on the colors. We get something that feels colorful but is not that saturated. So yeah, very happy with the workflow, and I will let you judge if that's something that looks good enough for you. Just so you can get a mind map of what I'll be talking about in this video, here's a quick diagram of my workflow. I split it up obviously in two parts, which is physical and digital. One of the first important points is that for this video, I'm going to focus on the digital part. I'm not going to explain what is my physical workflow. You can get a glimpse of it there. I don't consider it good by any means, like it's mostly janky, so it's mostly negative, something to hold my film. I have changed method between this photo, a backlight, which still has quite some importance when scanning. In my case, it's an iPad Pro. And which device I use to scan my negative, which in that case is a camera. And this is what my whole workflow is built upon, is using camera and especially getting raw files, and from there getting a positive so I can get a pretty image out of it. For the digital workflow, what we're going to see is in two parts. We're going to see kind of the pre-processing step that I have to do, which will be the small coding part. And then we're going to have a look at the positive development workflow, anything that is more artistic, which this time will be in Nuke. So you can see here on my screen, this is what Nuke looks like with one of my photo loaded. If you never heard about it, Nuke is a compositing software that is the reference in the VFX and animation industry. If you have seen any movie with a special effect in the past 15 years, you can be pretty sure that it has gone through Nuke at some point. So in conclusion, it's a very powerful software made for manipulating images, which is kind of what we want, I guess, for photography. So this is the website. I'm going to put a link there if you want to have a more detailed look. Know why I'm using it? Because it's a software I'm already familiar with. As simple as that. I'm working in the VFX industry, so it happened that I just started to use it also for my photography. But why I stick to it, I think it's because of the flexibility and trust it gives me over my workflow. And by trust, I mean I'm confident about what each operation I'm doing and what the software is doing. I usually don't get any surprise or unexpected behavior when using the software. If you already use node-based application, like Nuke is one, there is a node graph where you can manipulate nodes. You should probably know how much more control you get over the traditional workflow of using layer, like in After Effects or Photoshop. Though if you are not familiar with node graph at all, I recommend you to check the video that I'm going to link, which should give you a nice overview on the topic. Though for Nuke, I must now mention the elephant in the room, which is its pricing. If we have a look at the price, it's very expensive, which is a huge downside. But don't leave there yet. There is a non-commercial version that is free, and this is what I'm actually using because I'm not using Nuke for my professional work, so there's no way that I'm going to pay that amount, even if I really like the software. But obviously, this non-commercial version has some limitation. The first one is, as the name indicates, no professional work, which is not an issue for me. All my photography is done on the personal side. Then you will have the other major downside will be the export size limit. You will get a 1920 by 1080 resolution limitation, but there is some workaround that exists, which for obvious reason I cannot endorse, but I mentioned that they do exist. And finally, just so you are aware, Nuke actually have an open source alternative, which is also free, which is called Natron. The software is kind of a copy of Nuke. It's very similar, so a lot of what you can do in Nuke and what you're going to see, you will be able to transpose it to Natron. So depending on your concern and what you prefer, you might want to check it out. So then, should you use Nuke for your photography workflow? Probably not, or maybe. But in the case you are curious, the goal here will be to show you how I managed to have it working for me, so you can decide if that looks like an interesting tool to add for your photographic workflow. Okay, so to start, let's have a look at the most nerd or technical part of the workflow, which is pre-processing stage, which will be to we have some input, which are some raw files, and manage to add them in Nuke so we can start developing them. And it all starts with those camera raw files. So on my side, they are shot with a Panasonic camera, so they are RW2 files, which Nuke will not support. So one of the first steps of my workflow will be to convert those raw files to another raw format that will be much more supported by other software, which is the very famous Adobe DNG file format, which Nuke will actually support and allow me to use. So I can get you a quick example right here. So I will not show you with actual DNGs from my image, because as you can see here, one of the issues I will have is that it's corrupted. Nuke will not be able to read the DNG properly. I guess this is because there is some compression going on. So I'm just going to show you with another pictures from someone else. So this was from CR2 files, a Canon RAW. And as you can see, you get some very basic control in Nuke, which would allow you to delayer the image directly inside the software, which is very useful. We have some color space control and some very basic tint, exposure, shadow, and obviously the temperature if you want to change it. But even if it's cool to have that, I didn't choose to keep the DNG format and use it as a starting point for working in Nuke. Because I don't have enough control over the parameters that you can see here. I will get back on it when explaining my development workflow, but what I need to have is being able to delayer the raw file without any color transformation. So this means that there I will need some kind of color space which would be raw or native, which means that I basically want the raw camera color space of the file. This is part of my workflow, and this is something that Nuke doesn't offer me. So that means that I will have to delayer the file manually on my side before importing them in Nuke. And to delayer the file and store the result, I will choose the OpenXDR file format. The reason I'm using it is, again, because it's a file format I'm used to. As I'm working in the VFX industry, this is a file format that we are absolutely using everywhere. This is the standard across all the VFX and animation industry to share pixel data. Also, it's very versatile. You can encode it in a lot of ways to better match what you need for your workflow. And it has good support in Nuke, because obviously Nuke is a software made for VFX. There might be some downside compared to alternative like TIFF, especially for storing camera raw data. But I didn't perform any tests, so I recommend you to do your own research on your side if you really want to see what would be better than OpenXDR to store those. But on my side, I really like it, especially because of the compression method is offered. I'm using a Dura compression method, which allows me to get very light files. It's actually not. If we have a look there, for example, on my XR, you can see that it's slightly lighter than the DNG, but the DNG is probably already compressed. I cannot confirm this, but I assume that they are already compressed. So that's a cool thing. It's being able to have a file that takes slightly less disk space. And so to realize those conversion, this is where Python gets into my workflow. I'm using some script to automatize all of this workflow that I wrote myself. So you can have a look at the repository that I'm going to link again in the description. It's all public. There is some very light documentation. It's not, you don't need to be a programmer to use the code. You don't need to write code, but obviously you need some technical skill to be able to have Python installed on your machine to create an environment, even if now it's pretty straightforward, and slightly modify some variable in the script just to be able to use your own directories or your own parameters as you want. But yeah, so we're going to get into the technical part of the video. I'm going to showcase a bit of how it works, but if you don't feel like this is things for you, you can just skip to the Nuke part. I will be putting a timestamp so you can skip right ahead. But for those who want to stick, let's see how that works. So for the repository, if you never hit GitHub, you can download it as a zip by clicking on the green button and download zip. On my side, I will be opening it in my IDE, which is PyCharm here. There is a bunch of different stuff inside, but I will be using mainly two scripts for my photography workflow. So the first one will be RW2 to DNG script. This one is very simple, doesn't do anything fancy. So I will give it a directory as input, and then it's going to produce some DNG file as output. I automatically create a new directory that is called DNG based on the input directory. And for the conversion, I will just be calling the standard tool from Adobe, which allow you to create DNGs. So yeah, the code, there is really not much. I'm just calling the Adobe DNG converter tool after looping on all the file. Really simple on that side. And then the next part, once I get my DNG, I will run another script, which will be the raw XR converter. And that's the most interesting one. It's how do I take a DNG and I convert it to an OpenXR that has been debuggered. So for that whole process, that script is pretty light because it's only the high-level script that I'm using. So again, I'm just giving it a directory, and it will be able to automatically find the DNGs. Like I've got a quick function here, it's going to find the DNG and convert to OpenXR. It's going to place the file next to the DNG and rename them automatically. Like I don't have much to do. Basically what I always do is just here, I edit the input directory, here I edit the input directory too. I just run the two scripts, and that's pretty much it every time. But what's interesting is having a look at how that script exactly works. So we can now go inside clear here and raw XR converter, which is what is the actual tool being called. This is where all the code lives. So that's a command line interface. You can call the help or just check the argument to see what are all the options you can use. And let's see what's inside the big function. So to process the XZR, there are going to be multiple steps. The first one is that I'm going to use EXIF tool, which is again a popular tool you can find online, that's going to allow me to read the EXIF metadata from the DNG, so I can preserve it in the XZR. If we have a look at some of my XZR here, I'm just going to use another tool. There we go. We can see that inside my XZR, I preserved all the EXIF metadata that I got into the DNG. So all of that is thanks to the EXIF tool that I will just be calling and retrieving the metadata it extracts. And then we will get the debugging, the core of the workflow. For that, I'm using RawPy. So if you're not aware of RawPy, that's a Python library. There we go, that you can find on GitHub. It's open source too. And what it is, it's basically a wrapper around libro for Python. So what this allows me is this will use libro for debugging, and it will offer you an interface to communicate in Python and will allow you to retrieve a NumPy array from the libro debugging. And that's RawPy. Obviously, there is some debugging options that are important. So in my workflow, to debugger an XZR properly, I will have a few things, so we can have a look at where do I put, yeah, okay, so there we go. Here, this is the section where I create the parameters that are passed to Libro for debugging. So there is a few of them that are hard-coded, like the bit depth. I always want it to be maximum. I always try to ensure that the file is linear and the software is not doing anything automatically. And then there is a few options that belongs to the preset system I have, which is like the demosaic algorithm, median pass, and FBDD noise reduction. This is all for changing noise. And we have also the color space. That is an option that you can tweak. But yeah, then the debugging is pretty simple. ROPI will get an NumPy array, that will be in floating point that I automatically convert. Then here I will get some color space handling. So the way I manage the color space is actually a bit different for that script. What I do is I always ask ROPI to debugger in CIY XYZ or in row, meaning row that you don't do any color space conversion. This is what I talk about. And when you actually ask him to debugger in some color space, like for example, I want it to be debuggered in sRGB, ROPI is going to still debugger in CIY XYZ. But then I'm going to do the conversion myself in Python using another library, which I'm not sure why I did it that way anymore, but yeah, that's how I'm handling it. And then in the script there is yeah, a little bit of exposure handling that you can control arbitrarily. Also, if you want to bump the exposure into the file, as we don't have auto brightness enabled in ROPI. And then everything else that is in this function is just how the file is wrote on disk. So for that, I'm using the OpenImageIO library to be able to convert my NumPy array to an image that can be stored on disk, which in our case is an OpenXR. So all of this is just setting some metadata, nothing much more, and then at the end I'm writing the image. So that's what the tool is doing basically. Nothing really magic. But yeah, it took me quite some time to polish it and make sure that I got everything's right. Okay, let's get to something with less text and more pictures. Let's have a look at what's going on in Nuke. I'm first going to show you the theory behind my development workflow, and then we are going to see how does it work in the context of developing a full role. So the core of the film scanning workflow will be how do you go from a negative, like these images, to a positive image that you can just share on the web and is adjusted to your taste. For that part of the workflow, I decided to call it Loog. So you're going to be able to find it in the same repository that I show in the pre-processing part. Yeah, Loog will just be the name of all that workflow which take a negative and convert it to a positive. First, maybe before the theoretical explanation, let's just see how it works. So in the case of Nuke, I will have this node that I already pre-made that will basically be a template. So I'm just going to copy it here, and one of the magic of Nuke will be that I can just import it by pasting it. So here, if I do a Control V, I will have my node that is directly imported. So now let's take some pictures that I have that have gone through my debugging. I'm going to get on that later. But so here we have an XDR that is my scan of my negative that has been debugged from the camera raw file. And there I'm going to get it through my Loog workflow. So how the node works, I'm just going to disable it first, and the first thing that I'm going to do is sample the base of the negative. So this is basically a part that have not been exposed. So here I'm going to take this small portion here. And here, now if I enable the node, we can see that we already have an image that starts to look like something. It does have a very blue cast. So for that, I'm just going to adjust the white balance here. So for the white balance, I'm just going to increase the red, something like this, and then maybe just add a tiny bit of green back. Okay, something like this. And with that, I think we already have an image that is pretty satisfying. There is a last step that if we want to control, we can have more control over the exposure or the tonal adjustment of the image. So here I will have the slope, or like here I can make my image brighter, or I could make it a bit darker if I want. So now let's see how exactly does it works. I made a quick diagram to show you how Loog is built, what are the different operations that I use to convert my negative to a positive image. So this is the whole workflow, and we're going to get through it. One of the first important part of the workflow is that it starts at the moment you have a raw camera file, and actually even that the raw camera file is part of the Loog workflow. Here I did put other scan device that will probably not get you a raw file. Like for example, maybe if you use a scanner, you will get a TIFF file that is already deburred for you. But here the deburring is part of the workflow, because here I'm applying a special operation, which is I don't want any color space transformation when deburring my camera raw. Honestly, I cannot give you a really rational explanation of why I'm doing this. It's rather a gut feeling based on the research that I did that just get me to this conclusion that it's better to skip that part. One thing that I know by avoiding this step is that I'm avoiding negatives value when deburring my image, because basically that leaves me in the native camera space, so I will avoid having negatives value because I convert it to like a smaller gamut or anything else. So that's one of the advantage. I will move the problem kind of later, at least in the way that I do it right now. When I debur, I don't apply any color space transformation. Then the first step that we saw in Nuke is removing the base of the film, which is often called the orange mask. So for that, it's a simple division operation where I just sample the base of the film, or I divide it. That's very simple, but actually I think this part play a kind of big role in trying to get something uniform across different roles. Like for example, as you can see here, my original negative, like they all have like pretty high exposure value here. It depends what is the exposure shift I use when deburring and how I expose them when taking the pictures. They are kind of all different. But what the sampling of the mask will do is that here you can see that I'm sampling very high value, so it will kind of always balance it again to a more common range of value across different film stock or across different sessions of scanning. So that's a small step, but I think it play quite a big part in the overall workflow. Then we have the white balance that I also show, that allow me to usually the film will have kind of a blue tint, so this allow me to get white to something that I much more like. I guess this is supposed to be kind of a technical operation. This means that in theory, if you use the same scanning setup and if you take the same film stock, you could just copy paste your pre-made white balance value and use it as such. But I found myself that I'm sometimes using this as a creative control, like maybe I want my image with more of a green tint, so I will use the white balance. And I usually never copy paste value. I just, every time I start a new role, I just adjust them against until it looks good. So for the white balance, it's a simple power operation, nothing very fancy here. And then we have finally the inversion of the negative, which is converting the negative density to transmittance. And last, we will have the tone map curve that will allow you to, as I mentioned, adjust the exposure of our film, because right now here we will have something pretty flat, and we have inverted the film. So for that, you can see the tone mapping being just kind of a curve that is applied equally to all your RGB channel. This is usually referred as tone mapping. So there is a lot of different curves that exist with different control, or you can even just draw it manually if you really want that control. But basically, I think you could use pretty much anything at this step, or maybe just like this is actually even more part of the grading operation, I think, than it is kind of the technical step to get a negative to a positive. And lastly here, what I will show is where do you grade your pictures, because as you can see, we have different state of data. We are manipulating a lot of stuff, so where do you actually apply your grading? Because you could do it at a lot of place. In that workflow, I mentioned that we can do some pre-grading when directly on the negative, which would then be grading in a log state, because the negatives could be seen as the pictures with the log encoding, or you could just do it after, where there, depending on how you interpret the output of the whole Loog workflow, you would do it in kind of a non-linear fashion or more a linear type of grading. So in the first case, you can assume that what you have is already ready for display, and you just do a bit of grading. So then that would be some very kind of display referred grading that works for your monitor and what you see. And then here you just export the image and that's done. What you see is what you get, basically. Here we could do some non-linear grading, but then apply the transfer function. It's something that I have tried, the monitor transfer function. So if your monitor is sRGB, this means that here we apply a linear to sRGB conversion, but that would still mean that this is some kind of non-linear grading, because what we get from this is already a non-linear output. And what I found out is that usually if I do this, it affects the parameters here in the curve. I will tweak them differently than if I was not applying the monitor transfer function just after. And the last step, which I think is probably the cleanest workflow, or the one that sounds actually correct, is reverting the transfer function, or at least getting something that is more linear, because here the curve can be seen as a transfer function. So here I will just apply kind of a revert transfer function. Honestly, here I just pick like a 2.2 power function, so inverse power 2.2. So that means that when you grade, you kind of grading in a linear stage, and then you finally apply your monitor transfer function, which could be a power of 2.2, or this could be WEG 709, or this could be anything else. And now you might be wondering, now that I've started tackling about transfer function, you might be wondering where is the color management part in all that chain, because I've talked about transfer function, but what about the gamut, the primaries of the image? Where is the color space compression step actually? The reality is that there isn't. What I've found out is that it's just fine to assume that the image you're looking at as the output will looks okay for your monitor, and then just mean that it's bound by your monitor color space. So that means that when I'm doing all of this, there is like no color space conversion when I'm debugging, and all the operation that I did here, if I'm working on an sRGB monitor, I will get a picture that is in sRGB. And that if I want another color space for converting my image, then that means that here at the end I will do like a conversion from sRGB to I don't know, for example DCI-P3, and export it that way. And if I wanted to work my image in a bigger gamut, but then I would use a monitor with a wider gamut. I would work actually on a DCI-P3 monitor. So that means that all the operation I would do then would be for a DCI-P3 gamut. Which is something that I have not experimented yet, so actually I don't know if my workflow is accidentally just made to work better with sRGB, and that it would probably break with any other color space or anything else. Like you could also talk about, oh, I want my negatives to be in some kind of HDR, because right now all of this is SDR. Like I have an HDR monitor, how do I benefit from this and try to have my negatives looking better? This is something that I have not explored at all. I don't know at all if it's worth doing it. What I know is that right now, just sticking to sRGB and SDR providing me already very good looking image that I'm happy with. So I haven't looked anywhere else for now. Then you might ask me, is that workflow technically accurate, like all just what we see? Probably not. As mentioned, there is some part of it which have some trusted technical foundation. However, I would qualify the whole as a base product of my random experimentation. It just happened to work for me, but my conclusion is that I can produce nice image with it, image that I'm happy with. So that means that if you use it, probably you can too. Well, now that we have seen the core of my workflow, let's try to see how does it work in practice. I mean, when I get a role scanned, so I have all my rows, what exactly do I do to develop them all one by one? So again, I made a quick MD diagram so you can get a mind map of the workflow. So I will get here multiple raw files, one for each shot in my roll, or 2 or 3 depending on if I fail to capture a sharp enough image. Usually I may take more pictures. So they will all get through the pre-processing stage that I already showed. So for that, it's just I open my IDE, my code IDE that I show. I just edit in the to script the path of the directory where the raw files are stored. So those two are related. I just run the script, and that's pretty much done for the pre-processing step. Take me a minute or two. So then I get my dbred scan file, which are XCR. So I get again one for each shot, even the duplicated one or anything like that. I don't do any sorting at this stage right now. And then we get into Nuke. The first thing that I'm going to do is usually I will shot a color checker shot on my negative. And I will start by this one. So that means that I will do the workflow that I just showed. So we can have a look. Usually it's the last one of the roll. So let's take this one. Okay, so we have it. Then I'm going to this one. I'm just going to get here my Loog node. So I put it there. So again, I pick here an exposed part, I enable it, and there I will do my balance with Loog. So I will white balance it until I find something that is right. Probably something like that. Which then I will just use as a base. So that means that whatever I did here, I will just copy paste it for each shot and start working from this. So the gist of it is this is not a reference. This is just a starting point. This is just what I'm doing. So I could get some kind of a confident base for each shot. This is not a reference because obviously it all depends in what condition did you shoot the color shaker. Usually I'm shooting it under daylight, but daylight can change, and maybe all your shots are not actually shot under daylight. They may be shot under a fluorescent light or whatever. So it's going to look weird if I just keep applying the same setting and just consider it a reference. This is just a starting point. Then when I have this starting point, what I will do sometimes, not always, is trying to preview all the shots at once so I can start to make some cleaning and remove the shots that I feel are not good or that I don't want to spend too much time developing. So for that, I will import all the scans and I will group them in Nuke in a kind of grid shape, and then apply the checker log processing. Here I will just copy paste it, and then I will just check individually, like here in the image. Oh, I want to keep this one, I want to remove it, like for example this one. Okay, we're way too underexposed. There is probably no way I will manage to get this back in grading. And once I have this, then I will start to actually process the file one by one, so that I will start to build the node tree for all of them. So we can have a look at what the scene, finished scene looks like. So for example, this is my scene with all the shots in my roll. So here I have my color checker at the left, and then here I will have each shot with its log, and I have a bunch of other operations that I'm going to go over just after. Yeah, I forgot to initialize the exposure here. So a bunch of shots. You can see that I'm trying to have some organization for some shot to kind of find myself into this big scene. And then obviously the final step after will be to export the image. Once I'm satisfied with the shot, I will export them all at once. Usually I'm not doing it. I finish a shot, then I export it. Usually I just do it all at once at the end. It kind of depends here on my mood or whenever I want to post them online. To finish this, let's have a look at what other operation I could do on the node. So let's start by this shot, which is pretty simple. So this is my node tree. There is not that much node, so the Loog node is doing all the heavy work here. What I will do is first I will usually have a sharpen here that will allow me to get something that, as you can see here, gets a bit more sharpness. I think this all depends how you scan your negatives. Maybe your scanner is sharp enough and you don't have to. Maybe you actually need to. I just usually leave it. It's the default Nuke node with a sharpness of 0.8. Then just here clumping the negatives that may have been generated by the sharpen to avoid having my tool freaking out or getting some kind of weird pixel after. Then here, what I will use is a roto paint node. So it's in in Nuke. This is the way you can paint on your image directly without doing kind of procedural operation. What I use this node for is mostly cleaning the dust, scratches, or anything else that could be on the scan and that I don't like, or even sometimes just reshaping my image. Like, I don't know, there is like a sign I don't like in the shot, but I very much like the shot. I'm just going to paint out the sign that I don't like. Here in that case, I think, yeah, well, there we go. It was just to remove some dust that I didn't find pleasing on some shots. Sometimes I'm going to leave them because I like the vibe that they give them, but for some other, I don't like it. So yeah, just using the auto paint node here with the clone stamp tool. So basically cloning a part of the image and applying it at another place. Most of the time I'm doing this. So there we have Loog, and then here we just have some basic operation, because as you can see, if I preview there, we have an image that is on the side. So what I will be doing first is cropping it and then just flipping it until it's right, and that will depend on each shot. Obviously, I have to change this every time. And here, that part is for exporting the image. I'm going to get to it later. But yeah, this one is pretty simple. I didn't have any much modification, but we can have a look maybe at another one. Like for example, this one, I can see that I did put a grade node here. So what the grade node here is just some quick adjustment when usually the luminance balance here, I'm not satisfied with it. I will use some other node. So here I just did put small offset and a small gain, because I've got some shadows here that were a bit too much lifted for me, like yeah, kind of murky shadows. So just getting them a bit deeper. That's what I have usually when I do this kind of operation. I tend to use a new waveform. Yeah, the waveform. I will have a look at the waveform. I will go like, okay, you can see here between 0, that's why my shadows are lifted. I kind of have some room, and for that shot I don't want my shadow to be too much lifted, so I'm just going to drag them down. So I might look at for the highlight, do I have still some room for my highlight before they are getting clipped, and do I want them in that shot? Like in that shot you can see that it's pretty contrasty, you get a lot of shadow and very bright sand, so I kind of want it, not on all shot, I want them to be at maximum or very or have very deep shadows. Sometimes I want them kind of lifted. It's all depends, but yeah, I'm looking at the waveform to help me adjust that per shot. Yeah, like here you can see another advantage of not processing. You can really quickly copy stuff and just try different things on the side. Like, oh, I want to make some kind of different processing. Which one do I like better? Like in Nuke, then I just use the 1 and 2 arrow key to kind of flip between them. Which one do I prefer? Which one do I like? And for the operation, yeah, let's have a look at this one. Yeah, this one. I was not a huge fan of this shot. Like, I feel it was missing something, so I did quite more grading than usual on this one. We can have a look here on the 2 grade. As you can see, it's very minor. It was just trying to redirect the center of attention to what would be the subject, would be this statue here. And as you can see here, I will be doing some grading before Loog. So that means that here I'm grading directly on the negative. So that means that the grade nodes are going to behave differently than if I put them after. Here we're going to grade in a log space, so the controls are different. Usually here I'm going to use the offset that's going to behave like a gain and differently. What I do for that most of the time is I'm just building some mask, as you can see here. Some very basic mask with a radial shape, or sometimes I will use a roto, or sometimes I will use a ramp to affect where do I want to grade my image. And just with the grade I managed to get some cool modification. I think this one is the best example. Maybe we have another one here. Yeah, so we can have a look at this one. This one also still 2-bit flat, so I did some special adjustment. Here you can see I just darkened the bottom of the image and I brighten up above the image. So for that I have 2 ramp masks. So here another one for the top, another ramp for the bottom, and here just with a grade with a bit of color adjustment too, I managed to get something which is a bit more interesting to have a look at. And I'm doing this before the Loog node, and after I'm sometimes using it, but not always. But as you can see, for most of the shot, I'm not using a lot of grading. I just like them how they are. It's really depend. Yeah, something else I'm doing here, for example, is scaling down my negatives. I found out that actually for those I got quite some resolution. Like here it was quite big, not necessary to export at that scale, so I just did half resolution reformat, going them a bit down in size. There is here just the export quick that looks kind of funky, like why do I have so many nodes here? This one is just the way I found to kind of work around the Nuke limitation. It's a custom node that I've developed. I'm going to send you the link, but you can find it also on my repository. Basically what it will do, if I copy it here, so let's start fresh. What I will do is just click the button. It will lag for a few seconds. Still don't know why. But here then is going to paste me some nodes, and what each of these nodes will do is that it will split the image in a lot of small tiles, which will all have a maximum size of the resolution, and then you're going to be able to export all of them. So here, as you might want to have control over your export setting, all the nodes are cloned. This is another handy Nuke feature. For example, here, if I check raw data and create directories, you can see that on all the nodes, they are linked. I can also change the file format if I want. Here, for example, I'm going to just reduce a bit the JPEG quality. Then what I do is I select all the white nodes, I unclone them, Alt-Shift-K. So now they are uncloned. So like if I uncheck this, you can see that it's still checked here. So they are uncloned to be able to be exported. And then here I will press F7, which will bring the Nuke export dialog. I will click OK, and the nodes are going to be exported. I just forgot before, obviously this is where do we want to write the file. So here we have some expression that link the node. Here I have the export directory. This is where I will export all the tile. The individual tile are going to be exported there. And then here I have a file path for the combined image. The combined image is the image that will have all the tile combined. And for the combining here, you can see some of the options I'm using. I'm using other tool. You can check the documentation of that tools online that explain you how it's combined again all the tile outside of Nuke, obviously. And yeah, basically it's a two-step workflow. I then just do like this export. Okay, I wait for it to export, and then I just click the button combine from export directory, and with that there here I get my image in my directory that I want with all the resolution, and yeah, that's pretty much it for every shot, and I just rinse and repeat every time. Hey, so just a quick intrusion. I actually managed to have my workflow working on Natron. So if you're looking for an open source alternative, yeah, I mean that works pretty nice. There's not much to do. Like the gamma here, you just have to think to invert it. This is to make the image positive, and obviously I didn't wanted to implement all the curve formula, so I just drew it by hand for something that looks good, you know. So up to you if you want to rewrite the full formula, or if you think just put it in manually will work, but not much. And here this is just to remove the film base. I just sample this and do a manual divide with a merge. So hey, Natron can work for this, and it's pretty much the same workflow as for Nuke, so that's cool, I guess. Okay, and I think we have seen it all. You now know how I create digital scan of my film negatives as of the first month of 2025. Obviously, I wouldn't qualify my workflow or perfect or accurate or anything like that. It will probably evolve again in the future, but as it hasn't moved much for the past year, I thought it was important to capture its state right now, but maybe in the future I will get some correction going depending on your feedback. So which lead me to you. I hope this review of my workflow inspired you to try different approach, and that you got anything constructive from my rambling. Maybe it's something to try and to incorporate in your workflow. And with that, yeah, let me know in the comment if you have any feedback and critique on what I show. And on that, I leave you. Bye.